All right, what's up, guys? We're back again with another Zach cast, episode 3, I think. No, episode 4, looking at some more Rust code. So again, we're teaching Zach to write Rust. We're working on the Crawford programming projects, and I guess we'll let Zach. Yeah, he's showing us the projects with the horrible transparent equations. Um, we'll let Zach give us a little bit of background on what he's done so far. But other than that, let's go and get started.
All right. Well, I guess I'll just go ahead and hop right into doing a little bit of these bond links here.
Sounds good.
I think we finished everything last time, right? We read the data from each line into appropriate variables, and then it's just to close the file, but we don't really.
No, Rust does that for us. When the file, so I don't think we've actually talked about this specifically yet, but Rust has this concept of scope. Actually, most languages have this concept of scope. And that's the region of your program, usually the region of the text, really, especially in a simple program, where a variable is valid. And the way that Rust manages memory is that when things go out of scope, they're not accessible anymore, so Rust drops them. So there's a trait called drop and a function called drop, and that actually basically frees the memory.
Okay.
So that's what happens with files. You use the file. When the file goes out of scope, it gets dropped and closed.
Right.
Pretty handy.
I remember the last time we were working on these for a class, we were doing Go, and didn't we have to like tell it to close?
Yes.
Or we would have to, I can't remember what it was called, but we would open it and then we would immediately say, once we're finished with this, close it.
Yes.
That way we didn't forget to close it. Yeah.
Yeah, in Go it's called defer.
Yeah, that's what it is. Defer, yeah.
Yep.
Defer close or something.
Yeah. Defer file.close, something like that.
Well, I was just before we started recording, I was telling Brent that the last time we did these projects, I could not for the life of me figure out why we were for looping over anything or why we were even doing this. So to give you a little hint as to where we're going, today we're just going to be essentially practicing our for looping.
Yeah.
So the next step in this project, step number 2, is to compute bond lengths. And so you can see with this much better picture that in order to compute bond lengths, what we want to do is follow this equation here. And so the appropriate thing to do, I guess, is to start looping over X, Y, and Z coordinates. And so I'm assuming that we can do all of this in the same function, and it's not going to radically break anything. So I guess we'll start with, I guess we should make a new function, right?
You could. Yeah, you can if you want. Or you could just start... so this is kind of a refactor as well. But personally, just my taste is to put the main function at the bottom of the file.
Yeah.
And then I put utilities above it. Yeah, like that.
Okay.
That way, when it gets long, you go into the file and you just go to the end. And it's like, oh, here's the main. Yeah.
Right. Okay.
All right.
Well, let's see. So function, and then I want to call this.
Well,
I guess, what? So
we. No, go ahead. Go ahead. It's fine. It's fine. Don't let me. I won't derail you.
Okay. Well, if I'm doing something that's not normal for a Rust user to do.
No. This is totally fine. It's just all right. This is like a peek behind the curtain. Okay. I don't want you to change your behavior, but I'm just gonna tell you what I'm thinking. Okay. So I kind of think it might be a good time to talk about structs because that would be a good way to put all of this data together. So you see, actually, I think if you run Clippy right now, it would complain at you because logeom is returning a complex type. And actually, you can try that. So I really, the first thing I meant for you to do is actually run the code just so we see what comes out.
Oh, okay.
But while you're at it, we can go ahead and run Clippy.
Okay.
Because things are about to get more complicated. So a big thing that comes up a lot in programming is managing complexity. So you basically want to make things as easy for yourself as possible.
Yeah.
And so I'm a little suspicious that we're about to start feeling the effects of this complexity.
All right. Oh, what just happened? There we go. So you wanted me to, what was it, Clippy or?
Well, yeah, you can just cargo space Clippy.
Okay. Oh, where's the Y button?
Oh, okay. I guess it's not complicated enough yet to complain.
Oh, perfect. That's what I like to hear.
Yep. All right. Well, no problem then.
Okay. Well, I like what you said, so I'm going to do cargo run.
Yeah, just see what comes out.
Yeah. All right, perfect. So we get all of our different vectors that we had, and it printed all of those.
Yep.
Charge X, Y, and Z, and then it just printed the regular file back to us. Just for goodness sake, I guess. Yeah. Okay, so the learning about structs thing.
Yeah.
Would you like to elaborate on that?
Actually, I think it would be fine for you to go ahead and define your function, because I think the act of writing out the function signature is going to make my point for me. So let's go for it.
The function signature. What is that? Is that this thing up here?
Yes.
Okay, perfect. So I mean, we just call it probably bond length.
Sure, sounds good to me.
Like that, and then I'll do this, and then what do I want to return?
Good question.
Yeah. Well, I mean, I want to return the bond lengths.
Yeah. So I think in the project, sorry, I think in the project they actually just print everything. So I agree that you should return them, because that'll be nice for testing. So if eventually we want to like test to make sure you're returning the right values, that would be nice. But for now, I think they actually just print them. So if you wanted to just print, you wouldn't have to return anything.
Oh, okay. So if I didn't want to return anything, but I just leave it here? Or would I still need the...
So you can... Okay, yes, to be strict, you would say arrow, and then you would say open and close paren. Because open and close paren, actually just like Lisp, which we have talked... I know I'm not supposed to bring up other languages, but you've been writing Emacs Lisp for your config.
Yeah.
Just like in Emacs Lisp, open and close is like an empty list, or in Lisp it's equivalent to nil.
Okay.
So in Rust, this is called unit.
Okay.
So it's basically just like the empty thing.
Okay, that makes sense.
But Rust also allows you, just like main down below, you can, if you're returning unit, you can omit the arrow and the parens.
Okay.
So you can actually leave that out.
Okay. But so the point you were making, though, is that for testing purposes, we would want to return something.
Yeah, but we're not testing yet.
Yeah, but we want to return the value of the bond length, right?
Sure.
Okay. Well, then I guess I'll leave this out then. All right. Well, so I guess the first thing we want to do is we want to do a for loop over all the x coordinates, right?
Sure.
So, like, I would just say, following their example, for, I guess, hold on, I need to do, I'm getting stuck because I thought it would indent for me.
Oh, I think it's because you left out the closing curly brace.
Oh, that makes sense. Okay, all right, that makes sense. So I would do like for I in. All right, I see you smiling over there. I'd like you to explain what you're smiling about.
No.
Oh, I guess I should have looked up how for loops work.
No, you know how for loop. You're doing it right. I'm smiling because you're just about to realize some things, I hope. and it's right here. Okay, for I in what?
Yeah, that's right. Yeah, that's true. Yeah, that's true. I guess I would want to do for I in the contents of the vector x.
Okay, so there's also actually, this is actually not a computer science thing or programming actually. This is actually about the equation itself.
Yeah.
If you go back to, you might want to go back to the project. I mean, it would be really nice if we could see the equation and the project, but it's not a big deal. Okay, so what are we calculating here?
We're calculating the bond lengths.
Yeah, we're calculating the interatomic. Oh yeah, just read this. Calculate the interatomic distances using the expression where x, y, and z are Cartesian coordinates. You've got that covered. You've got your vectors. But take a look at what I and j are.
Yeah.
I and j denote atomic indices.
Okay. Oh, I see. Okay, so okay, all right, I get. All right.
So you don't actually want to go blasting down your x, y, and z vectors. You actually need some concept of atoms here.
I see. Okay, and this is, I think, where your idea of the struct was starting to come into play.
Yeah, I mean, you can do it again. You can do it without the struct. You can totally do it without the struct, and you can just do it with some slightly complicated indexing techniques. So it's up to you. If you want to, yeah, this is it's your choose your own adventure, right? We can back up a little bit and talk about structs.
Yeah.
Or we can do some indexing practice. It's up to you.
Oh God. Well, I feel like the struct would probably make the most sense.
Okay, sure.
I mean, I feel like that would probably make sense, but also I feel like maybe index practice is a good thing for me. But
well, I think we will do a lot of indexing in this in these projects in general, so
yeah,
it might be a good time to learn about structs.
All right, well that's fine. So let's learn about some structs then.
Okay. So actually, I think it might be good. Do you have the book pulled up still?
This book?
Yeah,
this,
that one. That one.
Book? Okay.
Let's see. Do they have?
Yeah, using structs.
Yeah, let's take a look at that. Because they might explain it better than I do.
Oh, look at that.
Let's see. Why don't you? Do you want to read the first paragraph to us? This is like a real class.
Are we gonna popcorn read?
Yeah, popcorn read.
All right. Structs are similar to tuples, discussed in the tuple type, in which in that both hold multiple related values. Like tuples, the pieces of a struct can be different types. Unlike with tuples, in a struct, you'll name each piece of data so it's clear what the values mean. Adding these names means the structs are more flexible than tuples. You don't have to rely on the order of the data to specify or access the values of an instance. Okay. Adding these names means the structs are more flexible. You don't have to rely on the order of the data. Oh, okay. Okay.
So actually, we skipped the tuple section of the book, but you've defined a tuple. Remember from last time. If you hop back to your code, so you're returning a tuple from your load geom function.
Yeah.
And I think you can probably kind of get a sense for what they're talking about here. Like all you know when you call this function is that you're getting back a string, a vec usize, a vec f64, vec.
Okay, so what? All right. So if I wanted to do this struct based on how they did it, I would say struct, and then can I just call it atom?
Sure.
Well, maybe not atom. I don't know. It doesn't.
It's
matter
okay.
Right
names aren't actually important.
Yeah. Oh no.
And you're getting a blue squiggle because in Rust we make structs with a capital first letter.
Oh.
But that's again very minor, not important.
Okay. So is this where I would specifically define a name like charge X, Y, and Z, and then what the type is that they are? Okay. So I'd do charge.
Can you hear that awful ringing sound from outside my house?
Barely.
Okay. Sorry, YouTube.
So this is a string. Do I need to do it? Yeah. Okay. So there's comma separated, and then X, which is a. Oh wait, hold on. The charge is not a string. Charge is a vec usize.
Yep.
And I need to do it like this too, where I do.
Yep.
Usize. Okay, perfect. And then this is a vec f64.
Yep.
Vec 64. Yeah. So what is that noise? Who's using their thing?
I guess it's probably a leaf blower.
Yeah, that's what it sounds like.
Either that or somebody's vacuuming their yard. Which sounds hilarious, and my wife and I actually saw a video yesterday of somebody vacuuming their backyard. We were like, what are they doing? They're probably on drugs.
Are
And
are
then
they collecting the leaves or something?
no, hold on. And then last night, my dad texted me, and
Oh wow.
he had a shop vac out in our yard, and somebody had backed into one of our trees, and their back window exploded. So he was vacuuming glass out of the yard. So now I don't question anybody vacuuming the grass. There's probably glass out there. I understand.
That's funny. Nice.
Okay, yeah, there you go.
This is a struct called Atom.
Beautiful.
All right, so now how is this going to change my function load geom? Because I would assume that I would need to put these in its own struct, right? Or I've already defined, I need to put this in something?
Yes, you defined the struct. Now, you could actually update your return value. So where it says string, vec, you can now say string, comma, atom. And get rid of all the vecs.
Oh, wow.
Because you're going to pack the vecs inside of a struct.
Okay. Atom like this?
Yep.
Oh, so cool.
Much nicer, right?
Yeah, that is. Yeah, that's a lot. Okay. So, I guess I don't want to jump the gun.
Okay.
But because I've defined these things down here the way that I have, does it automatically update the struct, or do I still need to change something?
No, you're actually going to have to construct a struct with those fields inside of it.
Okay.
And the way you do that is very similar to how you define the struct, actually. So you just say the name of the struct, open curly braces, and then the fields. And actually, in this case, because you have... This is actually a shortcut. So the full definition of a struct... Well, let's just go ahead and start writing it so you'll see what I'm talking about. Okay. So you can go down to your return value, actually.
Down here?
Yeah.
Okay.
So see, notice that we're still using a tuple because you're still returning both the contents and your atom.
Right.
But you've really constrained or reduced the tuple.
Right. So I'm still returning the string, but I want to also do the struct. So does that go in this line? Like what I do atom, open curly.
Yep. Yeah, and you see at the bottom it's telling you the fields.
Oh, nice.
So the full way that you construct a struct is that you say field name colon value. But there's a shorthand where if the value that you're putting in is a variable with the same name as the field, you can just write the variable.
So I could just do charge.
Yeah, you can just say charge instead of charge colon charge.
And then I could do the same thing where I do X, Y, Z.
Yep.
Okay.
And close the curly, and that's it.
Nice.
Beautiful.
That's cool. Oh. And so like down here, if I wanted to print would I be able to print the struct or?
No.
Okay. All right. That's
what I thought.
Hold
on. We can fix that. All right. Okay. Go ahead and comment out your bond length for now.
Okay.
Yeah. And in Emacs, if you visually select it.
Isn't it like alt comma or something?
Alt. I think it's semicolon.
Okay. You're right.
Yeah, why don't you go ahead and give that a run? I think you're going to get a compiler issue. Yeah.
Well, yeah. Well, I mean, I already see this here.
Yeah, so right now I think it's mad because you're still trying to unpack it like a tuple.
Yeah. So I need to change that, right?
Yes. Now, another cool thing about structs is that you can actually unpack them just like a tuple. So if you actually put atom, open curly brace, in front of charge, and then a closed curly brace after Z, you can actually unpack the tuple and unpack the struct all at the same time.
Oh my goodness, look at that. Ugh.
Yeah, so that should quiet down the compiler. That should be good.
Okay.
Now, are we necessarily going to want to do that in the long term? Probably not.
Probably not.
Because the handy thing about a struct is that you can pass it around as a whole thing. You don't have to pass around the individual fields. But that was just a minimal change that would silence the compiler
That's
error.
cool. That's cool that I can unpack it like that. That's neat. So if I wanted to compile this, it would compile.
Still compiles. So that's actually another refactor. So we've now refactored to use a struct.
That's awesome. Nice. Okay. So what more do you what more, oh wise sage of the struct would you like to would you like to pass on?
So now, well, first of all, you should format the file.
And then, okay, F6. Okay.
But now this next thing is actually a little bit computer sciencey. So in computer science, they talk about this thing called a struct of arrays. So a struct containing several arrays, like you have here.
Yeah.
Or you can have an array of structs.
Okay.
And the reason people, sometimes for efficiency, you may want to switch between one or the other.
Okay.
That's probably all I need to say. But the point here is that probably the simpler point here is that you've actually defined something that I might call a molecule.
Oh, right, instead of an atom. Yeah,
but if you wanted to, you could define an actual atom struct that instead of containing vectors contains a single charge X, Y, and Z.
Right.
And then you could also define a molecule struct which just contains a vector of atoms.
Yeah.
So that would change you from having a struct of arrays containing all the fields to you would then have an array of atom structs.
I see.
And if we go back to your equation, the indices we're going to be using are actually atom indices. So it might be convenient to be able to access individual atoms rather than access individual X, Y, and Z values from the whole molecule.
Say that one more time.
So yeah, if you go back to your equation, or the Crawford project.
Oh yeah, I see.
You need atomic indices.
Yeah.
So we've done a struct refactor. So I think it looks a little nicer. Hopefully you agree already.
Yeah.
But for usability, we might want to break up your arrays into individual atoms.
Yeah, that would make sense to me.
Because then if we have a vector of atoms, we can say, if we index the vector with I, then we know we're getting xi, yi, zi.
Yeah. Yeah.
Which is what we need for the equation. Yeah.
Okay, so that all right, that does make sense. So if I wanted to so this is struct atom, but really this is actually struct molecule.
Yeah.
Okay.
So if you wanted to rename it everywhere, we really need to make a binding for this actually, for eglot.
Yeah.
Do you mind taking a slight detour into Emacs config, or do you want to stay here?
No, let's do it, man.
Okay,
let's do it. Emacs.
Let me look this up on my other monitor. Yeah. I guess go to... Yeah, I guess Rust TS mode bind is fine. So we added one for eglot. Oh, we have one for code actions. Okay, but there should be... Let's add one more.
Okay.
I guess maybe Control-C-R, because this will be for rename.
Okay. Is it just eglot-rename?
I don't know. Could be. Check. The way I would usually check this is with meta x, and then I would just start typing eglot dash.
Yeah, eglot-rename.
Okay, perfect. Nice. It was a good guess, but you know, it's always worth checking.
I agree.
Yeah, sorry everyone on YouTube. The I think Jitsy's kind of slow today. We're not seeing you type sometimes, but that's okay.
Oh no.
Yeah.
Okay. All right, there we go. Eglot-rename has been rebound to CCR.
Oh.
Okay. What's the matter here?
Wait, you need to I think you messed up your parens. If the video is up to date. Wait, where did you run? Where did you eval?
Outside of this line right here. Oh, I see. I need to be out down here.
You need to take off the paren after eglot code actions, and then eval outside of the whole use package. Outside of the whole use package. Yep. Okay, good. It acted like it worked anyway, but
yeah.
It shouldn't have. Okay, good.
So now I want to do Control C R to rename atom to molecule. Look at that, baby. Man, that was cool.
Beauty.
Okay, so now I want to make a different struct, but for atoms.
Yeah.
Or for atom.
Yeah.
Okay, struct atom. Yeah, I hear.
Does what I said make sense? Like, do you see why you're doing this? I don't want you to do it just because this is how I would structure it.
No, I mean that makes sense to me. I mean, I think that if I had kept going the way that I was going, it would have gotten overly complicated.
Yeah.
And there wouldn't have been a need to do it that way.
That's what I thought, which is why I stopped you. Because I don't want to. I think the ideal scenario is you hit a pain point, and then we fix it. But I think it was going to take a while to hit the pain point, and I think it was going to be pretty painful. So
all right. So I think for me, it's like figuring out what a pain point is, and then at what point I really just don't know. I can't tell what's a pain point and I just don't know how to program.
Yeah.
So for me, that's what it is.
Okay.
Like because I don't know how to program, I don't know it's all a pain point. You know what I mean?
Yeah. Okay.
So like, I don't know. It's the you tell or saying, hey, why don't we consider using a struct is kind of like if I was in class learning a new concept, the teacher was like, let me give you an example.
Yeah.
So it's like learning about structs is an example of how to make this problem easier.
Yeah, I guess what I mean, maybe rather than pain point, is like I wanted you to get to the point where you're like, wait, I have all of my x's together, I have all my y's together, but that's not how I would want to actually view this data. Is there some other way I could structure the data? But I don't know. But yeah, and then you say, how can I structure the data? And I'm like, oh, do I have the thing for you? But yeah, I think maybe you wouldn't even ask that question if you didn't know about structs. So
that's what I'm saying. Is like because I don't know Rust and because I don't know how like other programming languages, it's just like I don't know at what point to start asking those kinds of questions.
Gotcha. See, I'm always like indignant. I'm like, this is awful. There's got to be a better way. Brent, what are you doing here? Why are you doing this to me?
Yeah.
But yeah, I understand. So yeah, I thought we need to learn about structs anyway. This was a good excuse. So
okay.
Because now you're able to talk about, like, structs are a tool of abstraction. So instead of talking about, I have a bunch of x's, a bunch of y's, a bunch of z's, and they're just floats. Like, now you can talk about molecules, you can talk about atoms, and you can do things with atoms and molecules.
Right. Okay. So this is a charge, right?
Yep.
But instead of a vec of U size, it's just a U size.
Perfect. It's just an Uzi.
Hey, you can't say that.
What?
This is cool. Oh. Okay. All right. So now I have I have an atom, which is just the piece of the puzzle, and then I have the molecule, which is the whole pie.
Yep.
So now down here, I would actually want to do what? Would I want to keep it this way? String and then molecule, and then how would I want to construct that?
Well, you might want to change your definition of molecule. Because remember, this is actually what I was getting at with the array of structs.
Right. Okay, right. So, hold on. I'd want to have. Would it just be one line of atom? Like I don't. Oh,
Yeah.
it is. Oh, nice. Hey, yo.
And you might want to call it atoms, since it's going to be a Well, I shouldn't spoil it, but it's going to be a vector of atoms.
Dude, I cannot believe you just did that. It's like a vec of what? Structs?
No, it's just vec atom.
Okay.
Well, but it's capital A atom. Cause it's a vec. Like when you define a struct, you're defining your own type.
Oh, I did. Okay.
So
I guess
just
I
like when you do vec usize vec f64, you say vec your type, your struct atom.
Okay, cool. Man, that's sick. That's dope. Okay. Okay. Wait, hold on. Pieces of structs are different types. I was wondering if I read that structs were also types, or you're defining your own type here. Because
Yeah.
you said that and that made sense to me. It was like when I define a struct, I'm essentially defining my own type of something.
Yeah.
Okay. I just didn't know if I read that here and I just didn't understand, or if
that might be on the actual number 5 page. I'm not sure. Oh. Yeah.
Oh yeah, look at that.
Yeah, custom data type, yes.
Perfect. Okay, great. Okay, so now that I've done that,
now you just follow the compiler errors. This is why I like compilers. Hopefully everybody you guys should look out. I'm gonna have a video you should have seen already about why I hate Python. You make a change like that in Python and it doesn't say anything. It's just like it'll just try to run it and then eventually it'll crash. But Rust will tell you, hey, you changed what's inside of a molecule.
Yeah. Molecule does not even have this field.
Yep.
But molecule does have the field of atoms.
Atoms. Yep. Now you're thinking with portals. This is what I know I talked about this before when we did these projects, but sometimes you can write things in code that don't exist yet. So yeah, it totally makes sense to go ahead and just write atoms inside of those curly braces. And then the compiler will be like, hey, I don't know what atoms is.
Yeah, because I've not made atoms yet.
Yeah, but then you can just go back and fill that in later.
I guess so. Okay.
Wait, on Jitsi it says atoms charge, and then it says X, Y, and Z still. So
that's because I've not deleted it yet.
Okay. Yeah, go ahead and feel free to delete that.
I didn't know if I needed to.
Yeah, you definitely need to delete that.
Okay. All right. So then, atom not found in this scope.
Yep.
Okay. Wait, but I think. Oh, I see down here. Okay, so atoms is not found in this scope.
Yeah.
I'm trying to remember what that means.
So we talked a little bit about scopes, right? That's where variables. A scope is the region of the program where a variable is valid. So maybe a simpler description of this error is you didn't define a variable called atoms.
But I thought atoms was the thing inside of my molecule.
Atoms, yeah, atoms is a field. Okay, yeah, this is where the shorthand I think gets you in trouble. Is that the full definition for constructing a struct is field name : variable with the right type. So one thing you could do here is you can say colon and then vec : new. So that will basically construct you an empty molecule.
Vec : new?
Yeah, just like you were using up above, right?
I see.
So this will satisfy the compiler, but it's not going to give you the right answer. So this is, yeah. So, call the function, just like you did up above.
Yeah.
So again, this is just to emphasize the full form of a struct construction.
I
I
see.
guess you're supposed to say initialization. I don't know. Making a struct is it's molecule. It's the name of the struct. Curly braces. Then you have all the field names followed by colons and variables or values or whatever.
Okay.
So this will be the compiler will be okay with this if you save it.
The compiler will be okay with it, but there's nothing in it, right?
Right, there's nothing in it. So this is actually, again, I don't want to derail us too far, but if you ever hear anything about test-driven development, where you like write a test and then you check if you get the, then you write the code to pass the test. They have this expression called red-green refactor. So first you write the test and it's completely red, like it doesn't even compile because the function that you're trying to test doesn't exist.
Yeah.
So then you write a minimal version of the function that passes that at least like compiles.
Yeah.
And so oftentimes you'll be returning something empty, but it will fail the test because you're still not actually returning what you're supposed to.
I see. Okay. All right, so I guess I need to put something in atoms, right? Because that's what it's asking for.
Yes.
And the thing that I want to give it is it's a vector of these variables, right? Because these variables are what make up an atom.
Yeah.
Okay. But these are already. Oh, but we don't want the vectors. We just want the one. Okay.
Right. So why don't you? Okay, just say in words before we've gotten away from this a little bit. I think saying stuff in words. We've just been looking at code. So so say in words what you're doing right now. Currently.
Well, I'm currently thinking about what I want to what I need
sorry.
to be.
I meant the code. Say what the code is doing right now.
Well, right now the code is okay, so I'm saving this new vector to atoms because that's what added.
Sorry, I mean the looping part. Not the new code we've written. For every line in contents.lines, what are you doing right now? Up a couple stuff. Everything we did. I guess we did this actually like 2 weeks ago.
Yeah, I'm saving all of these things to a new vector.
Okay, and you've got separate vectors for each thing, charge, X, Y, and Z, right?
Yes.
Okay, and what do you want to do now?
Well, I don't want to save them as vectors anymore, right? I want to save them as just it's one value.
Called what?
Called atom? Is that?
Yep. Beautiful.
Okay.
Okay, so why don't you try to construct an atom struct in that same region?
Oh my god. Okay, hold on.
Okay.
So all right, I need to create an atom struct in this region.
Yeah. So and something handy when you're refactoring is sometimes you can do it incrementally. So right now I'm looking at the charge line. So right now it's all on one line. You're indexing into line, you're parsing it, you're unwrapping it, and then you're taking all of that and you're pushing it into a list or a vector called charge. So something that might be handy for you here is to separate out the parsing and the pushing. So you might want to delete and make a new variable for the stuff inside of the push. Does that make sense?
Delete and make a new variable for the stuff that's inside the push.
Yeah.
So this here, I need to take that out.
Yeah.
And call it something else.
Yeah.
Okay. I mean, I guess I just put it down here for right now?
Well, if you're going to use it in the push, it needs to come before that. But yes, you can always switch the lines later.
Okay. Oh my freaking goodness. Okay. Just gonna call it stuff for right now.
Perfect.
Just stuff. equals this stuff. Hold on. Okay. Wait, okay, but I don't want charge to be a vector anymore. Right?
That's right.
So
but we're
I don't want this to be a thing. Like, I don't want it to be a vec new.
true.
I just want it to be something.
Okay.
So would charge just be this, or would, and then charge dot push would be, would I push it onto the atom, or?
Yeah, so this, yes, this exactly. So this is what I was getting at with pulling out the charge.push, x.push, y.push, because instead of pushing these values, instead of pushing everything, you're going to pack these into an atom struct and push that onto a vec of atoms.
Okay.
So that's why I was thinking about doing it incrementally. If you wanted to leave the code as close to what it was, you would just pull out all these pushes, and then you would have all the variables, and then at the end, you could delete all the pushes, and then do something different with the values. But yeah, I mean, we don't have to do it incrementally. I thought it might help, but it might not also.
Well, okay, so with what I just said,
yeah,
I don't want a vector. I just want the thing. So
yes.
would I don't know. Do I need to leave let mute charge equal something up here, or would I put it down here? That's what stuff is.
Yep, that is what stuff is. Yes.
Okay.
Yeah, and you are only going to use those variables on each line of the loop. So you can just define them in the loop.
Okay.
So you can actually get rid of all 4 of those.
Okay, go on.
Does that make sense?
Yeah.
Okay.
Okay, perfect. So I guess then I would need to do all of this, but for each of these.
Yep.
Okay, well, I can just do this, right? I can just do... Oh, man, I can feel your... I can feel the... what kind of cringe Vim tinkering is he about to do? I can feel it in my bones. Because I was just gonna do this and just 1, 2, 3, and then.
Or you pasting it? Yeah, for some reason Jitsy's really, really slow today.
Actually, I didn't want to do that. I just wanted to do this, and then X, and then Y and Z, RY, and then RZ, and then each of these are gonna be 1, 2, 3. Okay, so then instead of all this quap, I just want to do this Shift 4. But
now remember your. Oh wow, what are you doing?
What do you mean?
No, sorry, don't let me interrupt.
Oh, okay.
I think you might have forgotten to change something on the parse lines, but we'll see.
Well, no, because these are, yeah, right, because these are not, well, wait. Hold on. Yeah, right, because the charge is U size, but these are all
yes,
F64.
Yep. Yeah, that's all I was talking about.
Yeah,
I really don't know about these inlay hints.
Yeah, they kind of suck, like, not gonna lie.
I kind of like them when they just sit there, but when they have to move around like that, it's kind of jarring.
Yeah. Okay. So I've done these things.
Yeah, that looks good.
Right, but now I gotta remember what I was doing.
yeah. So this is actually this is one of the nice things about doing it in reverse, right? Where you write the thing before it exists, and then you fill in the gaps.
Yeah, right.
But yes, just remember.
I want to push these onto a vector of atoms, or I want to. Okay. Is that okay? So do I need to create the new vector, or is that what that is down here, or?
Yeah, we just did that to satisfy the compiler. What we actually want down there is just atoms, but then you have to define atoms somewhere else.
Right, yeah. So I would say, like, let mute. Would I say atoms here?
So again, this is a scoping thing. Where do you want to use atoms?
Where do I want to use atoms?
Yeah.
Well, I want to use it down here when I return it.
Right, outside of the loop.
Oh, so I need to put it before the if.
You want to use it outside the loop.
Oh, the whole for loop.
Yeah.
Okay. So let mute atoms. And this is an equals, and then this was the vec new, right? This is vec new, not new. New.
You're spending too much time around those cats.
I know. Right.
Okay, looking good.
Looking good so far, kid. So now I want to push this onto that vector. Or wait, hold on. All right. I think my brain is a little stuck right here. I'm trying to think about it though before I.
Yep.
So we have the new vector.
Yep.
Of atoms, and we have the pieces that go into that vector, and I want to push each of them to the vector.
No.
Perfect. Okay.
Okay. So remember, what type is atoms going to be?
Atoms is going to be a vector of the struct atom.
Okay. So what you're going to want to push onto it...
I need to push. Okay, wait. So that means I need to put charge X, Y, and Z onto atom.
Yes, you need to construct an atom.
Right. That's right. I need to construct an atom.
And push that.
I need to construct an atom.
So you can actually delete... You can actually delete your push lines.
Okay.
Because those variables as vectors don't exist anymore. You deleted the vectors, remember?
Yes. I want to make do I want to define the struct outside of the for loop as well?
No, because remember each what are you looping over?
I'm looping over charge X, Y, and Z, right? No, I'm sorry. I'm looping over the lines in the file.
And how many atoms are there on each line of the file?
There's only one atom.
Right? So where should you construct the atom?
Oh, in the for loop.
Yep.
But above this, right? Or in this if statement?
Well, yeah, where do you have all of the values that you're going to put in the atom?
In the if statement.
Right.
So
that's the only place you can construct the atom.
Okay. Okay.
Does that make sense?
I think so. So to construct the struct atom, I do that, right?
Yep.
And then one of these.
Yep. And it's helping you out down at the bottom. It tells you what the fields are.
Yep. So we've got charge.
Yep.
I don't need to do like dot push or anything? Or do I do need to do dot?
Nope.
No?
You're going to push eventually, but that's for vectors. So pushing is how you put something into a vector.
Okay.
But you need to have something to put into the vector first.
So is it literally just like this?
Yep.
Oh my fucking Lord. Okay. Oh my goodness, dude.
Okay. So now
we have
yeah.
No, now we have an atom. And so now I need to put the atom in the molecule, or the atoms in the molecule, or what?
Yeah. So now, all right, now you have an atom.
I have an singular atom.
An atom, and you have a vector called atoms. Now it seems
likely... Okay. Now I would need to do like atoms dot push or something, or
yep.
Yeah. It's atoms dot push, or would it be atom dot push because I'm pushing it onto something else?
So okay, we'll get more into this. I think now that we have structs, we can actually talk about methods, which are how you define functions on structs. But the dot always comes after a variable, basically. So atoms is your vector. You say dot push to call the push method on vector. And then inside of the parens for push, you tell it what to push onto the vector.
Okay, that makes so that okay. So I want to push atom.
Yes.
Okay.
But you want to push an instance of atom. Like you want to push an atom. You don't want to push the type name atom, which is what you wrote there.
Okay.
So actually on the previous line where you constructed your atom, you're not actually doing anything with it. You're just kind of constructing it in the middle of nowhere and abandoning it there.
Okay.
So if you want to hold on to it, you might have to assign it a name.
Okay. I mean,
does that make sense?
Like that?
Yeah, except how do you bind a new variable? Yep. Perfect.
Okay. What's going on in your brain over there?
My brain?
Yeah.
Oh, I'm just watching you.
Oh, okay.
I'm staring at the code because Jitsi like cuts out. It cuts in and out, and I can't tell actually when you're moving the cursor or not.
Okay. Well, now I don't need this, right? I don't need vec.
Right, because if you remember the issue from earlier, it says that name atoms is not in scope. Now atoms is in scope, so if you just delete the colon, you'll be good.
Okay. Okay. Perfect. Probably save that.
Okay. Yeah, looking good.
Oh, perfect. Oh yeah, that's from down there.
Yeah.
Okay. Oh man.
All right.
More refactoring.
How does this feel?
That feels like a lot that I just learned. Like my brain feels overloaded right now, not gonna lie.
Okay.
Oh man.
Yeah, I think in hindsight we should have refactored a little bit more just inside of the loop before we did the structs.
Okay.
Because what I was trying to get you to do was pull these definitions out, the charge X, Y, and Z. I was trying to get you to define these as variables and then push them onto the individual vectors.
Okay.
So I was trying to do, don't actually change the logic or don't change anything about the program, just extract some variables is what I was trying to do. Because then it would have said, and then we probably would have renamed your vectors before were charge X, Y, and Z, right?
Yeah.
So I probably would have suggested renaming them to charges, X's, Y's, Z's.
Yeah.
And then once you made this change here, where you had variable charge X, Y, and Z, it would have read like charges.push charge, X's.push X, Y's.push Y, Z's.push Z. So you have some collection of Z's, you're putting a new one in. And then going together with the struct thing, instead of pushing them individually into separate vectors, you're just packing them together into a single atom.
Yes.
And then doing one push of the whole atom.
Okay.
And then the other thing that we've done is because we introduced two structs, there's like this extra layer of indirection. So probably the best thing to do would have been, instead of returning a molecule that holds a vec of atom, we could have just returned a vec of atom initially. And then we could wrap it in molecule later if we really wanted to.
Yeah.
Does any of that help or make sense?
I mean, that makes sense.
But yes. So basically what we did, we mixed the refactoring of giving everything we're pushing a name. And then we also introduced the topic of structs.
You know?
Which, I mean, how do you feel about structs in general? It's yeah. I mean, do you want to?
No, structs are good.
Okay.
I like the idea. I like the idea of structs. I think the idea of structs is good
Yeah.
because it lets me, define that type.
Yeah.
Um, that will hopefully be easier to loop over when we get to the step of actually looping over things.
Yeah.
Um, I think so. I think that was good. Obviously, it's just the learning of how to put the structs together and
Yeah.
how to do all of this kind of stuff is still it's very it's all very fresh.
Yeah, I got you. Does it feel kind of intuitive, like when you build an atom like that down there, right? You just write. It looks a lot like the definition, right?
Yeah, it does. Yeah.
Okay.
I mean, it does. I mean, it does feel intuitive, but I mean, hindsight is intuition afterwards is always
Yeah.
2020, I guess. So like, sure, it makes sense now that
Yeah.
you create a vector of atoms, and then you break up each of these individual pieces
Yep.
into their own thing, and then you construct an atom.
Yep.
Like this, and then you push your atom onto your atoms.
Yep.
And then you make a molecule of atoms like that. I mean, that makes sense now.
Yeah.
So yeah.
Okay. Well, that's good. I mean, of course, the point is that you can do this in the future. So does
yeah.
It's okay for it to be intuitive after the fact.
Okay, good. Because in the moment, no, it's not intuitive.
Yeah,
in the
yeah.
Moment,
when you first started, of course
brain,
not. Yeah.
In the moment, my brain is screaming. It was like, man, I don't get it.
Okay, but does it make sense now?
It does make sense.
If you wanted to make another atom in the future, would you feel better about doing that?
Yeah, if I needed to make another atom in the future,
okay.
I think I'd be able to. I'd be able to pull up some resources and figure it out.
Okay, nice.
Yeah.
Now, I guess one other question: do you like having something called a molecule, or would you rather just have a vec of atoms? Because molecule's not doing a lot of work right now. So if you'd feel better getting rid of that one layer of indirection, I think that would be totally reasonable.
I mean, I think I would need to utilize it first.
Okay.
In order to really understand if I like the layer of indirection.
Okay. I just didn't know if that was bothering you. Like, if you'd feel better just seeing vec atom out on its own, then we could do that right now. But
it's not giving me a reason to bother me yet. So or it's not giving me a reason to make me upset with it yet. So I guess it can stick around for a little while longer.
All right. Sounds good.
Before we really go at it.
All right, let's tackle these last couple compiler errors and just at least get your code running again.
Okay. All right, so let molecule. I don't want all that.
Yeah, so if you don't want to destructure it at all, you can just give it a name. Like, you could just call it mol. Mole or whatever.
No, let mole.
Let mole.
And, that's so...
And another convention, variables are usually lowercase. So the types are uppercase, the variables are lowercase. Snake case is actually what people say.
Snake case. Oh, look at that. So now we can't even use that, right?
Yeah, but what you could do is debug the whole molecule.
Right. So I would just debug mole.
Moi.
Yep.
Now, this also is not going to work, but we can fix it very easily.
Well,
I just want you to see what the error says.
All right, so it says molecule cannot be formatted using... Okay. Help. The trait debug is not implemented for molecule. Add derive debug to molecule or manually impl debug for molecule. This error originates in the macro. Okay. So the trait debug is not implemented for molecule.
Yeah.
So how do I implement this trait for molecule?
C note.
Okay, but do I put that in?
You put it right on top of the struct. So this, anytime you see this like hash brace thing, this is basically tagging something. So you can tag structs, or sometimes you can tag expressions in certain ways, or sometimes you can tag a module. stuff like that.
Okay, so now if I do that, okay, in this, okay.
So this is what I was talking about in my Python video about serializing stuff. Okay, like it's the same thing, just replace debug with serialize in the video. It's like, okay, the compiler would tell me that the struct is not debug because some of its fields are not debug. Yep, exactly.
Okay. All right, perfect. Remove this mutt.
Oh no, no.
Why? Because we're not doing anything to it other than just putting it somewhere.
Yeah, you're not mutating it. I think you got one too many spaces. Yep.
All right, perfect.
Yay.
Let mutt. All right, next one. All right, fields in this struct. Charge. Adam has a derived impl.
Oh, that is okay. Yeah, so that's just saying that you're not using it yet. Which is a little silly. But there you go. That's what your molecule looks like.
That's beautiful.
It does look nice, right? You've got a sequence of atoms. They've got their own charges. Yeah. They've got their own coordinates.
Yeah, that's nice.
Yeah.
Yeah. All right, well, there you go. That's that.
All right, why don't you go ahead and commit that? Because that was a lot more refactoring.
Yeah.
And now I think we're ready to make progress on the project.
All right, stage. TC. There we go. Introduced structs.
Oh, that's why oh god, I've had the little sidebar from Jitsi open the whole time.
Yeah.
That's probably that's why it looked so bad. Well, sorry YouTube about the last hour.
Oh wait, I don't need to save that. I just need to do Control C, unpushed. Perfect.
Perfect. Beautiful. All right. Vibe check. I guess we just did this, but how do you feel? It felt like a lot.
It was a lot. My brain is like freaking out a little just because it feels I guess this is a good time for YouTube to know that at this point, if it was just me, I would have given up learning a programming language by now.
No.
Yeah, I mean, this is just so much, and like, this project, like, I don't have a reason to work on a project like this because in the research that we do, we already have stuff that does this for us. So like, this is not a problem that I feel is necessary to solve. But but let me at least say this. I understand that in learning to program, you need a project, and this is a good project because it is directly related with what we're doing to what we do, and so like I get the reason to want to do the project.
Wait, you picked the project?
Yeah, you're right. Yeah.
Honestly, okay, look, all right. I don't want to offend anybody, but honestly, this is not that good of a project. Like, you've basically learned, if we hadn't deliberately added structs there, you basically are done with the project besides some really painful indexing. Right? Yeah. Like, the rest of the project doesn't really have any programming per se.
Yeah. I guess Advent of Code probably would have been a better one to introduce.
I still think it's valuable to do this one because it's going to it'll give you some reps with for loops and stuff. Like, we definitely need to at least compute bond lengths and do some of the geometry.
Yeah.
I'm not sure we need to go as far as like diagonalizing the moment of inertia tensor because we're just going to have, although that gives us an excuse to add a crate. Like, that'll show us how to import a library. So we can turn it into a reasonable project, but strictly looking at the instructions, it's like I don't know. Yeah. I definitely see what you mean. And the middle section is going to be a real slog. Like, computing all of this stuff.
Like this here?
Yeah. Like, the 3, 4, 5 are, like, basically the same. It's like bond lengths, angles. So we'll skip some of it if it gets really boring. But
yeah,
there's still some more that we can unpack here.
Yeah.
I don't. Let me. Is there anything else I can think of for a more, like a better project? Not really something self-contained like this, you know?
Yeah.
Because advent of code, most of the time you don't necessarily even need to make structs. So this is nice because I think it was useful to make a struct to organize our thoughts.
Yeah.
Let's compute some bond links. I think there's still some use here.
Okay.
Unless you're really bored. I guess I keep thinking, like, is it useful for teaching? And I'm not considering, is it just boring? Like, if you'd rather do something else, we can do something else.
I mean, I don't know. I think we can give it a shot. I mean, just giving bond links a shot. And if after that it's just like, oh God, this is so boring, we can move on to like advent of code, or
Okay.
we can, what, isn't there, didn't you used to have like this thing, like, what was it? There's some website that you could like get Euler's.
Yeah, Project Euler.
Yeah, Project
or
Euler.
Euler,
just,
or like
yeah,
Euler, or whatever. However you're supposed to say it, I don't
know. Yeah. Okay. All right. Let's do that then. Okay. So. All right. So we've. Oh yeah. Hey, look! I forgot we already had this.
Yeah.
Man, you remember this from like 3 hours ago?
It was actually, let's see, 1 hour ago.
It was only 1 hour ago.
Yeah. Oh man.
Oh no.
Well, we can tell that Zach's not having fun because time's not passing quickly for him.
Yeah, everything's going by real slow right now. Is this what time dilation feels like?
Yeah, we're actually, this is actually a general, is it general or special relativity? I always forget.
Who knows, man?
This is actually,
it's especially general.
Okay. All
right. So a function to create bond links. Okay. All right. Mastermind of structs. I'm assuming this is where I want to start looping over pieces of structs, right?
Sure.
Perfect. Well, okay, so the project wants me to do something with this. It says to calculate where x are Cartesian coordinates and I and j denote atomic indices. Okay, so for this little thing, I want to grab the x coordinate of the ith atomic indice. Okay. Is this where I need to start accessing my atoms vector?
Yeah.
Okay. So how do I loop over a struct?
So I think, yeah, that's okay. I think do you know, sorry, I'm being like pedantic in my head and I'm like trying to fight it internally. That's what what this awkwardness is about. So I think what you actually want are two concepts that you looped into how to loop over a struct. So you can actually loop over a struct, but it involves doing something that we're not going to do yet.
Okay.
So
okay.
The two concepts you need to know about are how do you loop over a vector and how do you access a field of a struct.
Okay.
Because this will let you access the vector in, I guess I need to hold it like this. This will let you access the vector inside of your molecule, and then you can loop over the vector.
Sure.
Yeah. I guess
okay, so
all the pedant tree came out.
Okay, so how do I access a field of a struct?
With a dot.
Okay. With a dot. Is it this? Okay.
Yeah, it looks a lot like method calls. So remember we do atoms.push. So you can actually now do mol.atoms. But that assumes that you have a variable called mol in scope.
Oh. But mole.
Yeah, I mean, you can call it whatever you want. So this is okay. All right. So remember, actually, this might be a new thing for us. How do you pass a value into a function?
Pass a value into a well, you have to give the function the thing, right?
Yeah. So yeah, if you scroll down just a little so we can see main.
Oh, let.
Yeah. So well, no. Remember that you called load_geom inside of main.
Yes.
Okay. So you have your molecule inside of main. If you want to compute the bond lengths in a different function, such as bond length, you're going to need that molecule inside the function.
Uh-huh.
So you're either going to need to write the code that you're writing right now inside of main, or you're going to need to get mol from main inside of this function.
Get mol from main. Okay.
So how do you... Well, okay, where are you going to call bond length? Let's answer that first.
Well, I mean, I guess at least for the purpose of this project, I would call bond length inside of main.
Okay.
So that means I would have to define mol in main.
Well, you already have mol defined in main. But the mol that you define in main is not going to be accessible inside the body of bond length.
Okay.
Let's just write some code. So move your debug mol into bond length. This is good. We've been talking too much today, which I think is part of the problem. I need to stop talking and just like get you compiling code. Delete your for, okay. Delete everything. Don't delete everything. Just yeah, delete that, and try to run it.
Okay. Not found in scope.
Now the other thing you might want to do is if you're going to call bond length in main, just go ahead and put the call inside of main, where you want to call it.
Okay. Do I call it like I've called load_geom here?
Yeah.
Well, okay. Let mol. No, wait, that's not what I wanted, right?
Right. So let is for creating variables, and the reason that you did let on load_geom is because it was returning things that you wanted to assign to variables.
I see.
As you've written it, bond length doesn't return anything, so you wouldn't actually need to capture anything from it. So you don't need to use let.
So I would just do...
Yeah, you can just say bin.
I would just do that?
Yeah.
Okay. Perfect.
Okay. So what are you thinking right now?
Well, I'm thinking I need to get mol to be something that I can utilize.
Yep. Okay. I guess we haven't done this. So if you have something and you want to use it inside of another function, you do what's called pass it as an argument.
Okay.
So the way that would look inside of main is that you will put mol inside of the parentheses with bond length.
Like that?
Yes.
Oh, okay, that makes sense.
However, yeah, if you run that, we'll get some new errors.
Unexpected argument of type molecule. Remove the extra argument.
Which is not what you want to do. What you actually want to do is the opposite of that, is tell bond length to expect that argument. And
redo.
Yeah. Oh. Wow, it's taking this long to do this. All right, go to your init file real quick. I knew about this, but we never actually fixed it. Go up to evil mode. And in the config section of evil mode.
Yeah.
I think the function is called evil set undo system.
Okay, so oh wait. How do I do the thing? Is it an open paren here?
Yeah, that's fine. I'm pretty sure it's evil.
Yeah, that's what it said. Undo.
Well, yeah, but I think you have to say evil set undo system or something like that. You should enable company mode real quick, and it'll help us out. So meta X company mode.
Oh. Oh wait, where'd it go?
Yeah, you might have to type somewhere. And then backspace a bit. Yeah, evil. I'm pretty sure it's evil set. Dash undo. Yeah.
All right.
Okay. And then set that to quote undo dash redo.
Undo
single quote. Sorry.
Oh, sorry. Undo dash redo.
Yeah.
Okay.
And then make sure to eval the whole evil block. So yeah, close that paren and then eval the evil use package.
Okay.
Okay. Now go back and try to redo, but it might not work until... Oh, it did work. Okay, good. So undo redo is the built-in Emacs. I actually use undo tree, which is like something else we'd have to install. So undo redo is the native version.
Okay.
Okay. Now back to Rust.
We have to tell it to expect molecule.
Yeah.
Is this like is it just like expect dot?
Oh, sorry. I shouldn't have said expect because yeah, expect is a completely different thing. I just meant that you have to update the signature of bond length to show that it takes an argument. So it says this function takes 0 arguments, but 1 argument was supplied. So you've supplied an argument, but you need to update the function to take an argument.
Okay.
And the way you do that is, again, you say variable name :type. In the function signature where your cursor is.
Variable name :type. Okay. I see. So I mean, just
so if you want
mole.
If you want it to be called mole and it's going to be a molecule, then you just write that.
Yeah.
It takes one. I'll take 1 mole, please, of type molecule.
So cool. All right.
There you go. So now you're using mole. Yeah, let's take note of this. You're using mole inside of a function. Big steps.
Using mole. Oh man. Okay, now we're using mole inside of our bond length function.
Yep.
And so now you said that in order to access the field, I need to do...
yeah, give that a try inside of your debug.
Oh, I see. Wasn't it... What'd you say? It was mole dot something?
There you go. Company's helping you out.
Uh-oh.
Yeah, give that a run. It looks pretty similar, but without the molecule on the outside. Right, now it's just printing the vector.
This here?
Yeah, you
Oh, yeah. Oh, yeah. Okay.
Now, let's keep playing with debug a little bit. Why don't you print one of the atoms? Whichever one you want.
Okay, the first one.
That's usually a good choice.
All right, data moved here.
Oh, geez. Okay, I didn't actually think about this.
Move occurs because TMP has type atom, which does not implement the copy trait. Consider borrowing here. Oh, okay. Okay, I'll borrow. How about I borrow?
Yeah.
How about I ask for them? Like, actually, can I? Excuse me, sir. May I have another?
Yep.
All right. Hey, look at that. Okay.
Now, let's chain our field accesses. Why don't you print one of the fields of an atom?
I don't know how to do that.
Wait. Company did. Go back. Put the dot.
Put the dot. Oh, wow!
See, the little brick is a field.
Dude, that is so cool. Dude, that's so cool.
Okay, so let's keep that, and
Okay.
now proceed. keep that as our template, so we can refer to it.
Okay. So now proceed with doing some bond lengthy stuff. I don't want. Okay. Yeah, but now I get scared.
Okay, why don't you
Okay,
print
all right.
all the charges? Let's start there. So again, this is actually how I program, right? Like it's not all. You don't just like sit down and write the whole thing. Like I do this debugging myself.
That makes sense.
Um,
Yeah.
uh, I say, hey, what does this field look like? What does the first element look like? What does the field on the first element look like?
Right.
Um, yeah. So sorry, printing all of them means I was trying to imply that we should go ahead and fire up a loop.
Oh.
Yeah, you can't just print all of them at once.
Well, now I feel stupid.
No, that's a good guess. I mean, some languages let you do that.
Okay. Okay, so I'm gonna do this. Okay, so for I in hi, what are you doing? Huh? Yeah, you can come in. What? Okay. All right. So am I at least off to a good start right
Yep.
here?
Yep, that
Okay.
is how you start a for loop.
Do I also so do I need to borrow these values again?
Yes. Very
Okay.
nice.
Well, what can I say? Oh wait, I need to do this. Dot charge. Blah, blah, blah. Wait, hold on. How do for loops work again? Oh,
What
I
are you
see.
trying to
Yeah.
loop over? Yeah, yeah.
Well, I want to print all the charges.
Okay. So remember when you do the index, you're indexing a single atom.
Oh, right. So I would do that instead.
I'm waiting on Jitsi. No, remember you can't access all the charges at once. Although I told you that was a good guess. That would be nice if you could do.
Yeah.
Look at what it's telling you. What is the type of I?
I is an atom.
Yeah. And so you can now access I's charge.
Oh, like this?
No. Okay, maybe you do
Oh,
need to look at how for loops work.
okay. Sweet.
Remember, yeah, so for line in contents.lines,
Uh-huh.
we then use line inside of the loop.
Yeah.
So maybe you want to rename I to atom, since it has type atom. Because that'll just make everything sound a little better.
Okay. Okay, so for atom in
So tell me what you
okay.
want to do again, just in words.
Oh, I just want to loop over the charges of the atoms.
Well, let me tell you what I want to do.
Okay.
I want to print. I want you. Let me tell you. Let me tell you what I want you to do. I want
Okay.
you to print each atom's charge.
Okay.
So phrased that way, what you've written so far is for each atom in atoms. This is why in Perl you can actually write for each instead of just for.
I see.
For each atom in atoms. What did I want you to do?
Print the charge of the atom.
Yeah.
Okay. So is this done right here?
Yeah, you need some curly braces and then you need to actually do something.
Okay.
So that is, yeah, you're done with the actual for loop syntax.
Okay.
Yeah.
Yeah. Hold on. I can't just type charge, obviously, right? I need something else.
Yeah. So what is charge?
What do you mean, what is charge?
In Rust terms. What is charge's relationship to atom?
Charge is a vector in atom, right? No? Okay.
No, remember the atom holds a single charge. Remember we've got our template. I told you to leave the template.
Yeah, I didn't know that's where I needed to start accessing that information.
Yeah, if you want to print each atom's charge, you just print atom.charge.
Okay. All right. is it just atom.charge, or do I need that whole this whole thing again?
No, just atom.charge. So yeah, what we were doing in the template is we had molecule, right?
Yeah.
At first we debugged the whole molecule. Then we debugged molecule.atoms. So we accessed the atoms field on molecule. And we saw what that looked like. Then we added the brackets to only print the first atom.
I see.
And then we added .charge to print the first atom's charge.
Yeah.
Okay, so what you did with the for loop is for atom in atoms, you essentially access, inside of the for loop, you're accessing each one of the atoms in turn. So that's just, the for loop is basically just like if you had run mol.atoms of 0, mol.atoms of 1, mol.atoms of 2, and so on.
Atom is taking the place of this index here?
Yes.
Okay.
And so then you call the whole thing you have there, ref mol.atoms braces, you've called that atom. So you've assigned each one in the loop to that, and then you just call atom.charge.
Okay.
So that should work.
Oh, wait. Error originates in the macro dbg.
Yeah, so the important part of this one again is expected unit found usize. And that's just because you don't have a semicolon again.
Oh, okay.
So it basically thinks that you're returning the last charge from the function if you don't have the semicolon.
I see.
And there you go. You can see all the charges.
Okay. Okay. I think, okay, so if I wanted to take this idea and start actually accessing the X, Y, and Z components.
Yeah.
Okay. I think my next question is, how would I oh, okay, wait. Would I need to have like okay, just for atom I and then a for atom J, or is that thinking too hard?
Yeah, that sounds reasonable.
Okay. Okay. So like on this, if I were to just take what I have right now, if I wanted to say for atom, and then if I put an I here, and then I do the same thing, but I say for atom J in, let me borrow this real fast, mol dot atoms. Oh no. Okay. So now I've accessed atom I and atom J, and now I want the X component of atom I and atom J.
Yep.
So if I just print real quick.
Yeah.
If I wanted to print atom I dot X, can I do a comma and print the other one?
Yep.
Atom J dot.
Perfect.
And I've already closed this one here and here. Okay. Oh yeah, forgot. Oh, I see. I don't really, I'm just going to get rid of this. I don't want it right now.
Nice.
What is that here?
Oh, that's actually the old error still.
Okay.
There you go. Looking good.
Feeling pretty good. Okay. All right. I'm understanding that now.
Good.
I guess now I need to do some math, huh?
Now it's just math. Yeah, exactly.
Now it's just math. Okay. All right. So how do we do math in Rust?
I think it's
Like,
probably how you would expect. I hope.
I speak for everyone, including all of YouTube, when I say that I doubt what I'm expecting is what you're hoping that I'm
Well,
expecting.
the first step is how you would expect. So let's go back to the distance formula.
Yeah. So I just want to do this part right here, right?
Yeah.
Okay.
So the power is definitely not what you might expect, but the
Yeah.
subtraction is the usual way, as
Okay.
I might say.
Well, would I want to save? This is probably more than it needs to be as well. But so if I want to do like the way that I'm thinking about this in my head is to do it piecewise.
Yeah, that's fine.
So X's.
Okay.
I guess would it be let mute or just let? It would be let mute because we want to do something with it later, right?
So again, I always default to not mute, and then
until it tells me to mute.
If I end up needing to mutate it, I'll add mute later. Yeah.
Let X's equal the subtraction of atom I dot X. I can just do minus like that, and it'll work.
Yeah.
Atom J dot X.
Just like a calculator for the arithmetic parts.
Perfect. All right, so the X's are doing this thing.
Yep.
Okay. So now I also want to square it.
Yes.
Okay, so how do I?
Yeah. Now the easiest way to square it is probably to put those in parentheses.
Okay, just like a calculator.
Yeah. Okay. Yeah, like calculator.
Okay.
And then so just like other types, remember like vector, we did like vector push. What else have we done? That's mainly we've done parse on strings, right? Methods.
Dot squirt.
Floats also have methods. Yeah, it does actually have a square root. But we don't want the square root yet.
Yeah, sorry, that was my brain stupiding.
So the function you'll want to call is powy. It's pow I.
Okay, powy, and then what I just do 2?
Yeah.
Okay. Okay, cool. That's kind of neat.
Yeah.
Nice. And that's so cool. And now I can do the same thing, but for Y and Z, right?
Yep. Y and Z, of course.
Yes, Z, of course, yes. R, Y, R, Z, and then I'll do the same thing over here. R, Y, R, Z.
Perfect.
Okay, nice. Now I want to put it all together.
Yep.
So now I need to do, I gotta remember how to do this. Oh yeah, okay, so. Let BL, I don't know if this is what you would do, but this is what I would do, equal X's plus Y's plus Z's. And then is there the dot squirt?
Yep. You typed it so fast the company got scared, but yes, it is there.
Okay, perfect. Whoa.
That is not the right formatting, but it will work.
No.
Now that's actually what they do in OCaml.
Oh, BL. It says is that already something?
It's unused. So let's debug it just to get rid of that warning. Let's see it. Yeah.
Oh, you mean run it? Run the code?
No. Like if you say you're not using BL, you're just assigning to it. That's what the warning is about.
Yeah.
So if you dbg BL, that will get rid of the warning because you're using it by debugging it.
Oh, you mean like under this line?
Yeah.
Okay. I see. So dbg.
Yep.
B.
Borderlands.
Yeah, good one. BK. Chunky's dead. All right.
I was mad about your semicolon again.
Yeah, dang it, dude. All right, perfect.
There you go. You're computing all the bond lengths.
This is so cool.
So I guess we can go take a look at the Crawford project if you want and check your answers. So they're not going to be in the right. They're not going to be in the right order or anything, but
yeah.
At least we can see if some of the numbers look the same.
Solution. All right. Well, 2.84511. Hey, look.
There you go.
All right, that's good enough for me.
Yeah, one and done. That's it.
One and done. One at a time.
We spot checked it, so they're probably all right.
Yeah. Yeah, they're okay.
All right, cool.
And this is the rest of the project.
Yeah, pretty much.
Some variation of this over and over again.
Yeah.
Okay. Man, I was all right. After this, I felt like I was flying.
Good.
But I mean, nice. Okay. Wait, do I want to? I don't. Yeah, I would want to save the bond links as something.
Yep.
Or I'd want to return the bond links, I guess.
Yeah, so there are a couple things to do here. Possibly. Yeah, so returning them is one thing we could do. Another thing we could do is try to mimic their printing style, where they show the atom index and then the bond length.
Sure. Yeah.
Yeah, it's up to you. I mean, this is good. Like, yeah, I hope you felt pretty good about this. So that's how you loop over a vector right there. Oftentimes you want to borrow it so you don't move the vector away. And then you access the vector by doing .atoms on mul.
Okay.
Yeah, but that looks good.
Nice.
I think the index thing might be useful. I think we should probably do both of them if you want.
Yeah, I mean, yeah, that's fine. Yeah, we can do that.
Okay. So, all right. This time we'll be stricter. We'll be more careful with our refactor.
Okay.
Okay. So this looks good, right?
Yeah.
So, this is some syntax sugar, this for loop.
Okay.
Okay? I think I mentioned this last time, but for loops have this magical interaction with what are called iterators.
Okay.
So when you do a for loop, it actually calls a method on whatever you're looping over. So this is actually equivalent to for atom I in mul.atoms.iter.
Yeah, okay.
So you call the vec iter method, and that returns an iterator over the vector.
Okay.
Which the for loop can use. So Rust does that automatically for you, so you don't have to write .iter. If we want to get the indices, we actually are going to want to call iter ourselves. So without changing any functionality yet, just call iter yourself. So let's do mul.atoms.iter. And you'll see why we're doing this when we do the second stage of the refactor.
Okay.
Yeah, you'll see now you get an awful function signature. Or, I guess, type signature. Oh, we might have to remove the borrow.
Okay. No, wait. I want it to tell me.
Sounds good.
Consider removing, deleting. Okay, there we go. Perfect.
Yeah.
Consider not borrowing it and just taking it.
Yeah, so the other magic trick that it's doing with the for loop is a for loop. So this, hopefully everybody who is about to make a comment about for loops calling iter will see this part. For loops actually call into iter for you.
Okay.
But when you call into iter, it moves the thing, like it consumes the vector and it becomes an iterator. It really does transform into an iterator.
Okay.
If you want to leave the thing behind, you call .iter, which for loops also do magically for you if you borrow the thing you're looping over. It calls.
Okay.
I don't know if it calls into iter on the borrowed thing or if it just knows to call iter instead. Something like that. It doesn't move it. But if you call iter yourself and then you try to borrow it, then it tells you, oh, this borrowed iterator is not an iterator. Only the iterator itself is an iterator.
Yeah.
So that's why you had to do that. Okay, so now if you run it, it should work exactly like before.
Perfect.
Okay. Now, the reason we did that is that iterators have a nice method called enumerate, which, instead of returning the item itself,
returns its index?
It returns a tuple of the index and the item.
Oh, okay.
So if you, after each of these iter calls, you just add .enumerate, so you can chain these. So this is what's nice about methods. I think we talked about this maybe in the first video, or maybe last week or something.
Okay.
Where you can do mol.atoms. Or no, we looked at this in P's Q's.
Oh yeah.
Where you can chain the calls to these methods.
So I do mols.atoms.iter.enumerate.
Yes.
What happened? Hello. Okay. Oh, I see what I did. .enumerate as iter. Like that.
Yep, just like that.
Enumerate.
And now, yeah, the type hint is actually helpful. The type hint is helpful here. You see that atom I is now a U size and an atom.
Yeah.
So if you actually look down a little bit into your main function, you can see a way to unpack a tuple into two different things.
Yes, I can see that. Yes.
All right. Now apply that pattern here. Well, actually, go ahead and try to run it. Go ahead and try to run it, because it's not going to work.
Perfect. Oh.
Does that make sense?
Yeah, no field X on type U size ref atom.
Yeah, so like I said, and like your type hint says, atom I. Uh-oh. All right. What the heck? That was weird.
Yeah, it was.
Okay, so the type hint is telling you what happened.
Yeah. So X belongs to the atom, right? It doesn't belong to the U size because the U size is the index.
Yeah.
Okay. So I have to unpack it.
Yep.
How do I unpack it if it's like a for loop? Like
it looks a lot like the thing down in main. That's why I told you to look there before.
Okay. So
wait. Sorry, but you can do it in the for loop. You can actually destructure or unpack. Okay, hold on, you're going the wrong way. Oh, colder, colder, warmer, hot, on fire.
Okay.
Yeah, you can do it right there. This might be kind of confusing. This is kind of magical as well, I guess.
What I say for okay, all right.
Yeah, just give it a guess. Give it a guess.
I mean, would I say for let?
No let.
See, okay, perfect. So,
because you can think of the for loop as introducing a binding just like let. Give it a guess. Give it a guess. Yeah, hot.
Okay, wait. So what well, so atom I want that to correspond to ref atom though, right?
Yeah. So that's the second element in the tuple.
So for atom I in atom.
It's beautiful. There you go.
Man, this is crazy stuff. Oh no. Okay. Okay.
Great.
Perfect.
Just to mention this, you gave them both the same name.
Oh, I see how that could be a problem. Well, this is just index I and this is just index J.
Yeah, there you go.
Perfect.
J. Okay. So yeah, why don't let's debug all three now. You can do index I, index J, and BL. And then,
nice.
Yeah, now your output's going to start looking more like what they print.
All right. Indexy.
Yep.
Indexj. And bool.
Personally, I probably would have called them just I and J, but yeah, no problem.
Man, look at that.
Yeah. Yeah, so enumerate is quite handy.
Yeah, that is kind of, yeah, that's cool. Oh, I see. Okay, that's neat. So there's the bond length for atoms 0 and 0.
Yeah.
Yeah, yeah, right. And then 0 and 1, 0 and 2, 0 and 3, 4, 5, 6, 1 and 0. Okay, cool.
So something you've noticed here is you're computing the bond length of something with itself.
Yeah.
If you wanted to skip that, do you have any ideas what you might do?
Well, I mean, I would assume that I would need some form of like if statement.
Yeah.
So like if I equals J.
Yeah.
Don't do this thing.
Yeah.
Or I could say if I does not equal J.
Yes. Sure. Yeah.
Okay. So like would I put that here? So like if index I?
Yeah.
Oh, nice. Okay. If index I does not equal, is that how I do that?
Yeah.
Index J. J is right there. And do the stuff here.
Perfect.
Nice.
There you go.
Nice. Oh, dude, that's so cool. Nice. So what about these okay, so index I and index J 0 of 1. This looks like it's doing the same thing down here.
Yes.
Okay. So how do I tell it not to do the combination or the same but backwards combination? I don't know how to phrase that.
So the easiest thing to do is probably to adjust your if statement.
The current if statement?
Yeah. So yeah, you can loop it into this. I think the other ways would be more complicated. So you could change what you're looping over. The other thing you can do, I picture this like a matrix actually.
Yeah, I just want the upper triangle of the matrix.
Exactly. So what you can check, so right now you're checking that you're not on the diagonal, just not equals.
Yeah.
So instead of not equals, you could say greater than or equal, or less than or equal.
Oh, okay. Is that so if I wanted to do just greater than or equal to like this?
I think I actually said it backwards. I think since you're printing it when it's not equal, you actually want to either print when it's less than or greater than. But you can try it. Again, this is like, you just try it. I don't actually usually think about these too hard. I just try it and it's like, well, that doesn't look right, so I'll try a different one.
Okay.
So yeah, you'll see now because you put less than or equal, it's printing the equal case again, so you just take out equal.
Oh, I see.
So yeah, and either less than or greater than will work.
Oh man, look at that. Oh, that's cool.
Very nice. Yeah, and I think that should be basically what they print out.
Yeah. Does this also take care of whether or not these atoms are actually touching each other?
No. I think they like hard code a check that the atoms are less than 4 angstroms apart or something.
Oh. Okay.
So you probably have a little more output than they do, but yeah, that's just... Okay. That's something they don't even mention in the instructions, right? Like, that's only in the solution.
Yeah.
But yeah, you can do that if you want.
Because, I would feel like you would only want to calculate the bond distance if there are 2 atoms that are bound together.
Well, so they don't actually check that. Now in my work, actually, this is kind of an interesting thing that we don't think about when we're doing... ab initio calculations.
Yeah.
Because in ab initio calculations, you just throw the coordinates in, and
Yeah.
it figures out where all the electrons and bonds are, like for you.
Yeah.
When you're doing molecular dynamics, you actually have to think about what atoms are bond together.
Yeah.
So a lot of the times, or all the time, we have to come up with what they call topologies, or basically graph representations of the molecule that encodes all of the bonds.
Okay.
So this, I mean, the 4 angstrom is like an arbitrary cutoff. It doesn't actually check that they're bonded, but to check that they're bonded is a very difficult problem.
Oh no. Okay. Yeah. Well, then we can move on. That's fine.
Yeah.
That's fine.
But I mean, if you want to go look at their solution, and I think it might be nice to print these in a little bit of a better way. We can talk just a little bit about string formatting if you want.
Sure. You want to talk about string formatting, and then I think we can call it a day.
Yeah, sure.
Okay. So, let's talk about string formatting then.
Yeah. So you've got the basic idea down below with the print line. So let's start with something like that. So instead of debug, let's just do print line.
Okay. Okay.
Okay. Now apply what you learned from your other print line right here.
And I'm assuming that, is it the same case for like this one thing corresponds to this one?
Yes.
Do I need to have 3 sets of those?
Yeah. And the compiler will actually help you with that. If you only put one, it would be like, whoa, there's only one.
All right, well, let me try that just for fun.
Yeah.
Okay, cool.
But it is only one string. The first argument is a string literal, so you need multiple sets of curlies inside of one string.
Multiple sets of curlies. Oh.
I should have let you compile it, because that would have actually made the compiler more mad.
So like this?
Yes.
Okay.
Precisely. Now, if you want to line them up nicely,
yes,
inside of the curlies, you can put a colon and then a width. So this will probably be most pronounced, in the first one.
Colon and then a width of...
Yeah, we love %5ds, so let's give it a colon 5.
Okay.
So that's how you do it in Rust. So like instead of Go or C or whatever, where you do %5d, in Rust you just say colon 5.
Nice. Look at that. That's cool.
Yeah.
All right. So now, what if I want to? Would it be the same? Okay. So would colon 5 for the BL reduce? Not reduce, but like would it cut it off at the 5th decimal?
No, it'll cut it off at a width of 5.
That's what I meant, not decimal, but
yeah. If you want to adjust the precision, you put a dot. So you could do 5.2 or something, or 12.8. You know, I guess that's what we use a lot.
Yeah. Look at that. Look at that.
Nice. There you go.
That's so cool. Man, that's neat. Cool.
All right, so let's recap what you've done so far, because you've done a lot.
I have done a lot, yeah.
You read a file. So in this, okay, and I think it's important to recap here because what you've done is very useful for any project, basically.
Yes.
You've read in a file. You loaded data from a file.
Yep.
You turned it into a struct that's easy for you to work with in the program.
Yes.
You've written a function that takes a struct and does some data manipulation on it, and then you've printed it out in a nice format.
Yeah.
So that general scheme is actually what most programs are. Real-world data, convert to a useful structure inside the program.
Yeah.
Do some kind of processing on that structure, output it in a nice real-world usable format.
All right, that's cool.
There you go. You've basically conquered all of programming.
I'm so proud. I'm so glad that I've conquered all of programming. Well, I guess this is the end of the series. Oh, man.
I think you're right though. This might be a good time to try Advent of Code, because that'll give us, you'll have like a fresh start.
Yeah.
With all of your newfound insights, and it'll just be some practice on some of the basics that we just did. Like Advent of Code, you always have to load a file. You always have to spit out some output. So
yeah,
you don't always have to make structs and stuff in Advent of Code. Sometimes the problems are pretty simple, but
yeah.
But yeah, I think that's good. You feel good?
Oh man, I think I feel okay.
Well, that's all we can hope for.
That's right. Yeah, that's right.
Okay, cool.
All right. Well, I guess this is gonna wrap up at least this particular project. The whole thing. I'm not doing the rest. That's too much stuff. Actually, I think one thing that I would want to do is so we have to save. Well, we have to use the bond angles in order to do the bond lengths in order to do the bond angles. Right?
Oh, I'm pretty sure they actually like recompute them.
No. Okay. Well, I mean, I'm assuming that if I wanted to save the bond angles, I would just save them into like a vector.
Yeah.
Okay.
One thing to consider, I guess, is that you might want to save them with their indices.
Yeah.
That way you can identify what they actually are later on.
Oh, okay.
So for that, you can use tuples again.
Okay.
Yeah, I mean, I don't know how quickly you want to get out of here, but we could do that. We could also...
yeah, let's at least save it as a tuple.
Okay.
That way, if we want to come back to this project later and finish that way it's already there, and we could just go from there. So, like...
Oh, the one other thing I was going to suggest...
Yeah.
Is that when you're passing an argument like this, you see we have mole molecule?
Yeah.
We could define this as a method on molecule.
Okay.
And so then you would call it as mole.bond length.
Oh, neat. Okay.
So if you want to see how you just define a method, that would be a really quick change.
Okay, how do you do that?
So if you go up towards your molecule... I mean, you can do it right here, actually. Sorry, we won't scroll around. So the way you call it an impl. So we're going to implement molecule.
Okay.
So you make a block that says impl, IMPL, molecule.
Above
yeah, do it above bond length, because we want this to be inside of it. Impl molecule, yep. Open curlies. Yeah, so this is a block, and then you put all of your methods or associated functions inside of this.
Nice.
And then close it after bond length.
Close it after, like the whole function.
Yeah, close the impl molecule block after the bond length function. Yeah.
Okay. Okay. And so now down here in func name, would I do like mole dot bond length? Oh, so
yeah, instead of bond length mole. Yep.
Mole dot bond length, and I can get rid of this.
Yep.
Dude, that's so cool.
And that should work. Let's make sure. Ooh. Okay. So apparently to call it like that, you actually do have to change the argument to self.
Ah, okay.
So you can actually get rid of mole : molecule and just put self.
Oh, nice. Whoa. There we go. Wait, I can do what? Mole : self?
No, you just change the whole thing to self.
Is it ref self?
Yeah, let's do ref self.
12.
You can do plain self, but yes, ref self is actually good. But now mole is not defined. Now mole is called self.
Okay, so I have to do that. I have to change it in these spots too.
Yeah, you just write self instead of mole.
I don't want that. Oh, that's neat. Okay. Oh my lord. Self. Dude, stop it. Self.
Yeah, there you go.
Okay.
So great, you just transformed your function into a method on molecule.
Neato. Adam has a derived impl for the trait debug.
Oh yeah, it's still mad that you haven't used charge.
Oh, yeah. It'll be alright.
Yeah. What else were we gonna do? Oh, we made self. It's now a method. You can call mole.bondLength. What was the other thing? Oh, saving them. Saving the bond lengths.
Oh, yeah. Saving the bond lengths.
Okay, So now, now use what you learned up above about vectors and tuples to save and return the bond links.
I want to save and return the bond links and their indices.
That's what I would suggest. Yeah.
Okay. So that means that this function would need to return something.
Yeah.
Okay. And if I wanted to return the thing, so the index is an integer, right?
Yeah. It's actually the inlay hints are telling you what they are.
Oh, I see. Yeah. So would I say that it returns a U size like this? Yeah. Okay. And then this thing is a string, so F64. Right.
So do you want to return one of the indices or both of them?
Oh, both. So then I would want to do another U size.
Yep, perfect.
Nice.
Oh, and then do you want to return one of those or many of those? Tuples.
Many of these.
Many of the tuples, right?
This whole thing is this whole thing being a tuple.
Yes.
I want to return many of them because I want to be able to access all of them. So what I need to change? Would I change these to the things? No, because that's.
Wait, let's see. I don't actually know what you're saying. So let's see what you're saying in code.
What I was saying was.
Yeah.
Like this. Or no.
No, that's a syntax error, but perfect. I think the idea is right. What do you want to do? So remember the angle brackets are greater than less than are for specifying types. So it looks like you want to specify a type of something.
Yes.
And if you said you want to return many of them, I'm guessing you want to return a vector.
A vector. Yeah.
So you are going to need some less than greater thans.
Like this?
Okay, so this actually gets back to the first thing we did today. Do you want to return a tuple of vectors, or do you want to return a vector of tuples?
A vector of tuples.
That's what I would suggest. So in that case, you would leave the parens, you would add less than greater than on the outside, and then you would slap vector in front. Yes.
I see. Okay. That makes sense.
That right there is how you write vector of tuple.
I see. Okay.
So yeah, I think you wanted to do the right thing, but you just didn't know how to say it, maybe.
Yeah.
Yeah, that looks good. Now it's obviously very upset because you're not returning anything, but that's the only reason it's mad.
Yeah.
I don't know why it highlights the whole function, but it's like the whole function is bad. It doesn't return the right thing.
Yeah. I would want to do this outside of the for loop, right?
Yes, very good.
Right here. I'd want to return, or I want to do this, right? Or no, I've already, wait. I'm trying to remember how we want to do this. So if I were to return a vector of tuples, we don't have to push anything, right? I do need to push stuff.
Yeah, so remember the pattern from earlier. We initialize an empty vector. Inside of the loops, we push stuff into it, and then we return the vector.
Okay. All right, so that means inside the loop, I need to push to a vector.
Yep.
But I need to initialize an empty vector first, or we already did that because the return type is a vector?
No, in Go you can do that trick, but in Rust you do have to initialize it.
Okay.
Yeah, in Go you can have a named return value, which implicitly initializes it.
I see.
You might be remembering that, I'm not sure.
I don't know. So let's see. What do I want to call this vector?
I often call mine ret, since I'm going to return it.
Nice. Vec, : new. Okay. Vector of an unknown type. Do I want to be explicit with it here, what I'm returning? Or does that
no,
matter?
it'll infer it once you actually use it.
Okay. So underneath here, could I do like ret dot push, and then I want to push index I, index j, and then the bond length of the two of them.
Beautiful.
And then now
the one thing you're missing there
is the semicolon.
The two things you're missing there. To construct a tuple, you actually do have to wrap it in parens, and it always looks weird when you do the push too, because you have to have two sets of parens.
Wait, so I here and I put it here?
Yes.
Okay.
Yeah, because push takes one argument, so to make those three things into one tuple, you put another set of parens.
Okay.
Yeah.
And so now underneath here.
Yep.
I want to return that.
Yep. Up one. Yeah, this is another confusing thing about the impl block is that it adds another set of curlies.
Okay, yep, so now I want to return ret.
Yeah.
Oh my lord. There we go.
Yeah. And actually you don't need the parens because the reason we have parens above is because we're returning a tuple. This time just a vector, so you're good.
Okay. I can see here that it's going to want me to put mute probably.
Exactly. And you see your inlay hint actually figured it out this time. Now it knows the type of ret.
Okay. This is upset about something.
That's just an old error. It doesn't update until you save it. Yeah.
Oh, okay.
Yep.
Nice.
There you go. Yeah, that was perfect.
Nice. And so now because that returns something.
Yeah.
How would I? Oh, okay. Well, I don't know. But I guess we can talk about that next time if we wanted to move into it.
Yeah.
Okay. Perfect. Well,
give it a run. Give it a run. Make sure it still works. But I think it should.
All right.
And as one trick, well, no, I guess we shouldn't do a trick. Never mind. It'll mess it up.
Yeah. No tricks. No tricks.
Okay. Okay. Great. And now we can also, if you're interested, we can also do tests. So now that you're returning it. If we're just printing it, you can't really test it, right? Like you'd have to like read what you're printing to yourself and then test that.
Yeah.
But now that you actually are returning a vector, you can go through that vector and compare it to the output from the project.
Right.
Yeah. So that's really good.
Well, I guess I'm gonna go ahead and
commit that.
Yeah.
Look at that! Look what you did. You took your little bond length comment. You made a method. Yeah. Oh, it's beautiful.
Yeah. Man, I don't know what all to say. Made a bond length. Wow. Made a bond length method on molecule. I guess I don't need to say on molecule because you see it right there. Made a bond length method and additional refactoring.
Nice.
All right. Right now it's what is it? Is capital P for push?
I think so, yeah.
P. And we're done.
Money.
Well,
right.
I guess I think I'm gonna call it here for this video.
Sounds good.
I hope that this was instructional content for at least somebody out there.
Yeah.
I hope it was educational. I hope somebody can relate to me when it comes to wanting to have given up, but obviously I'm pushing through now because I don't want to just give up because that seems a bit silly. But I
for one am very proud of you.
I appreciate it. So I hope somebody can relate, and if you do, I feel like coding is a very useful skill to have. So don't give up. Be better than me. That's what I want. I want someone to watch this video and go, I'm better than that guy.
And next time maybe we'll try to have some fun. We'll play Advent of Code.
Yeah, next time we'll have fun, This time it was just terrible, I hated my whole life.
Oh.
I'm Jake. I'm just kidding. Okay, well, I thought that was fun.
Yeah, good.
I feel like once I got here and I realized I was like, okay, now I kind of know. I guess I understand. And once I understood what we were doing in this part, I think that I got it.
Yeah, I thought that was good. That would be the only reason I think to continue with bond angles is just to, you know, make you type that at least a couple more times, but that's that might be overkill.
Yep.
Yeah.
All right, well, everybody, I hope you had fun watching. Consider liking and subscribing. If you want to see more stuff like this, let me know. If you want me to not do this ever again, tell me. You know, I can't fix what I don't know is broken. But anyways, I hope you guys have a good rest of your day, and I'll see you next time. See you later.
Me too. Right, thanks. See you guys next time.